Hello, everybody, and welcome to the Apache TinkerPop 375.380 post-release review. Just get the slides up here. Today we're going to be breaking down new new releases from TinkerPop. We're mostly focused on new features. We got some new steps. We got some type changes and some grammar changes. Get the slides up here. See. There we go. Yeah, so we're going breaking down the releases here. Joining me today, we got Stephen, Yang, Andrea, and Ken. So thanks everybody for joining me. And let's get into it. So to start, we're going to go over the agenda here. We're going to start by breaking down the 380 upgrade guide. This is one of the biggest releases we've had in a very long time. We've restructured the upgrade docs a little bit to make it easier to navigate. So we'll just do a quick overview of that. Under the same theme, we've got a new AI upgrade risk assessment where we get to use a new prompt to have AI help focus your upgrade on your specific code base, which is really cool. So we'll do a walkthrough of that. We've brought the air routes toy graph straight into TinkerPop. Many of you will already be familiar with that data set, but we'll do a quick demonstration there. Then we'll break into some of the data type changes and some new steps we've got. And we'll go into some grammar. And lastly, we'll focus on some of the changes that have come to 375. So to get started, I'll pass off to Andrea to break down the upgrade guide.
Hi everyone, my name's Andrea. I'm a recent addition to the TinkerPop committer squad, and I'm just going to talk about the upgrade guide, which looks a little bit different for this release. This release has more content than the usual release, so for convenience at the top, there's a table included that organizes the changes by impact level and the type of change. And the impact level can be a breaking change, which means it's not backwards compatible with the previous release. Or a brand new feature or a deprecation. And a deprecation in this case means the feature will be removed in a future release, but it's still backwards compatible with 3.7. And each item in the table has a link to the relevant section of the guide where you can read more information about that specific change. And the body of the guide itself is organized such that the changes that are similar are grouped together. So if you're looking to upgrade to 3.8, it's recommended that you pay close attention to the breaking changes to determine if your queries are affected and if they need to be modified. To help with that, there is an AI risk assessment prompt that's also included in the guide that we will discuss next. And next slide.
Okay. I guess I'll talk a little bit about the AI risk assessment. I think, as was kind of noted here, this was a fairly large release, and one of the issues with dealing with TinkerPop upgrades is finding all the places where something might be different. In this particular case with 3.8. There was a lot more cases where you might find a problem, and you'll need to update your code. Whether that means fixing something as simple as a compile problem, all the way up to something a little bit more subtle, where Gremlin semantics have shifted slightly, such that you might not get an error, but you might get maybe even a different result. Maybe something orders differently or just behaves a little differently, and you'll need to account for that in your code. I mean, luckily these days we now have these AI coding tools that do a pretty good job some of the times at finding issues with our code and generating solutions. And so we kind of came up with this risk assessment prompt that will help identify those kinds of issues. So this should help ease upgrade concerns a bit. If you have a large code base, you should be able to use this prompt to help at least give you a sense of things you should be looking at. I mean, this is by no means some excuse to like, let AI take over here and do everything for you. We really need to understand the changes that are coming in the release as you move to upgrade. However, this can go a pretty long way to helping find some of these problems and give you some things to think about as you go about planning, planning the upgrade process. So what I'll do is take the screen here for a second. Where am I here? And so, so to showcase this, I'll use the Kiro IDE. I don't know if everyone's familiar with Kiro. I'll pop up the QR code there so that you can have a look. But Kiro is an agentic AI-driven development environment that's really good at spec-driven development, where you first kind of focus on crafting this well-defined specification the agent can use to better generate what it wants. I don't know. I've only tried it out for the last couple of weeks or so, and I actually really kind of like it. So it's definitely been useful for certain things that I work on in a day. So I figured this would be a good place to a good way to kind of demonstrate usage of this tool and this prompt. The one of the challenges in coming up with this prompt was the deciding how to test it. Like, how do I know that what I've written here, what we've produced here, is going to give us, somewhat consistent results? How are we going to know if it's actually finding things that, that are problematic? And to do that, we came up with a kind of a small but also realistic sample application of some complexity for that purpose. And so we could basically write a 3.7 application, run this prompt over it in various tools. Different tools didn't just use Kiro, used IntelliJ, used different models from Claude to ChatGPT and so forth, to see, just how close they could come, what needed to be changed and written in this prompt to try and work across the vast majority of tools, and eventually came to something that seemed to work pretty well. So this is the prompt on the screen, and I'll make it a little bigger. And you can see Kiro is not so different than VS Code, if you're kind of familiar with that, or any other IDE for that matter. But on the left here, I have the TinkerPop code base over here. And in this here is the specific prompt that we use. This is something that you could copy and paste directly from the upgrade documentation, but it's also kind of embedded in the code as well if you knew where to look. So let me see, the application, the sample application that we use for testing, which I'm going to kind of use here, is hidden away in this docs folder, particularly here in this upgrade Java directory. And I don't know, it's named Java mostly because it's, I don't know, I kind of thought that in the future there would be maybe sample applications for JavaScript or maybe for Go, and that way you'd be able to test multiple languages with this upgrade prompt in the future. So just kind of left some options open there. This is the sample application is a CMDB database and CMDB application. And if I could just pull open the right file, oops. And so configuration management database and an incident knowledge graph. And it exposes basically a REST API for that type of graph. And so you could, if with Kiro, you could open up the chat, and I've already kind of had, but you'd start a new session. I already kind of pasted this in here, but you could just paste that prompt directly into the chat and run it, and it would essentially examine the whole code base and find the things that are Gremlin, and particularly come up with this nice report at the end that tells you all the things that might need changing. But I kind of wrangled it in a little bit in this case, just because I kind of know what direction where all the code is inside this that's Gremlin related and what isn't. And that's likely something you'd want to do yourself, right? Like you don't necessarily need it pouring over millions of lines of code if you know exactly where it should be going. So with a little bit of extra context there, you can probably save some time. If there's particular classes, doing them one at a time might make some sense. You kind of need to tune your context a little bit to make sure you get the most out of this. Potentially running it multiple times after making some changes might give you slightly different results. That's another thing I've kind of noticed with this. Like you might get sort of different looks depending on, again, not only the model, but like, again, what changes have happened to it in between runs, to the code in between runs. But again, it as you'll see in a moment, it definitely does a pretty decent job of doing of finding things. So you can see here. Let me see if I can make this any bigger, maybe. So you can see here we have the context of this traversal builders class, which is here and has all of the. Close this for a second. Basically has all of the Gremlin in our application. And so it will go through all that and find things of interest. I did make one edit to this prompt, which is right here. Normally this says your tasks are to thoroughly analyze the entire code base. I swapped out entire code base specifically for traversal builders. .java, and that's pretty much it. Once I send that off, Kira will start doing its thing. You've all probably seen plenty of agents doing this kind of work. It goes and it'll grab the upgrade docs. We've isolated the upgrade docs specifically to 3.8 so that this isn't reading all the upgrade docs, which is like a massive body of stuff and just serves to do nothing but confuse the model. By isolating it, it's helped tremendously in getting things isolated specifically to 3.8. That was actually a change for us. That's not typically how we write our docs. So we can already see how AI is sort of changing, how we think about documentation and all that kind of stuff. Like all of that is starting to matter. I just realized I've been hiding my face the entire time behind that QR code. Anyway, so you can see it generated this nice report. It's interesting. I have actually multiple reports here. This was the one. Let me pop it. Oh, I do have it open. Okay, sorry. Which one was it? Sorry, I lost track. I have a few open, so I just want to make sure I'm pointing to the right one. It created this one here. Okay, now I got it. Close this, and we'll close this. So you can see from our report that it noticed that it found a usage of nonstep, and in 3.8 nonstep has been renamed. It's been repurposed, and it should be discard instead. And so we can see that method uses the nonstep, which has been affected by the none renaming. So it gives you all this nice information. But I think what's helpful too is it's like, okay, well, you need to make sure that you instead use discard in those cases. It found something here related to the use of split in this case, and also the tail step where there were semantic changes, and it wants you to go look at those and make sure that you're make sure that you're not using it in a way that's unexpected for the new semantics. Notice repeat. It's going to find a lot of issues with repeat and point you to those sections and lines where that's being used. So that was kind of cool. There was also, I think also you kind of get the idea there. I had another run of this. I think it was this one. This one was a run from IntelliJ with Junie and their AI assistant, code assistant. And so it produced almost similar sorts of results. I presume it was using, I'm not sure what model it was using underneath. So in this case, I'm not sure how well to compare them. Presume maybe they use the same model, and that's why they got so close to each other. But they also produce similar things. I think a nice little feature of it is it doesn't do too bad a job in giving a confidence level. I thought that was kind of important. That way you could look at high confidence level, like if it wasn't sure that it was really like this breaking change you need to focus heavily on, it was nice that you could be like, okay, well, let me jump to all the high issues first. That way I'm not spending a lot of time on just, AI dreams. So I think this will be, like I say, a really helpful tool for just getting a sense of what your upgrade task is going to look like. This should give you like a nice roadmap to like get an initial understanding of what's going to be involved. So I kind of look forward to seeing how we develop, what kind of feedback we get from this. Like, do people find this? Will they use it and find out that it's incredibly useful? Or is it? Are we going to need more refinements here? I do worry that at least we had some kind of test bed, but I do worry that the little test application is sort of was maybe was not as big as it needed to be, or maybe it was a little too tuned to the 3.8 upgrade problems. So I don't know. Like I said, interested in hearing what kind of feedback we get from this from people who end up using it and figuring out how to make it better on future releases. So with that, I think that's pretty much it.
That's great. Let's get back to the slides here. Yeah. So next, I'm going to jump into the new air routes graph. And actually, before I get into this, I remembered I forgot to mention, if you have any questions throughout the stream, feel free to post them either in the Twitch chat or in the events channel of our Discord. We will be monitoring that throughout the presentation. Some questions we may try and take live. Most of them we'll answer at the end. But yeah, feel free to post them if you have any questions. And with that said, I want to get into the air routes toy graph. So many of you will already be familiar with air routes. It was originally built for Kelvin Lawrence's Practical Gremlin book, which many of us have used to learn Gremlin for the first time. It's a really great data set to learn and explore Gremlin. For anyone who's unaware of the schema, it's mostly composed of airport nodes, and then there's edges representing anywhere there's a route between two different airports. And then you also have a mix in there. There's continent and country nodes, which the airports can be contained within. But the bulk of it is just in this airport and route linking. It's by far the largest data set we have built into TinkerPop now. It's at about 3,700 nodes. The Grateful Dead graph used to be our largest graph. It's about 800, so it's quite substantially bigger. And it's a really great data set to sort of learn to walk through a graph and explore your data, because its size and also its simplicity of the schema. Something like Grateful Dead, you've got more of a mix of different node types. So it can be a little bit harder to navigate. Also, if you're not familiar with the Grateful Dead, their music, you're not going to be familiar with the data right out of the bat. Where air routes, everyone can kind of just jump right into their local airport, and it's something they understand. They'll be familiar with a lot of the places nearby that are connected to it. So it's very familiar, very easy to get into and explore.
It's worth noting that we're pretty far along with the second edition of Practical Gremlin at this point, so I may as well take a minute to plug that. As you speak about air routes, I think this is like a pretty important second edition. I know it's been in the works for a long time, but we've only been able to work on it as there has been time to do so. But I think with this release of 3.8, it's like really important to get that second edition out and up to date for folks, because like just so much has changed as we'll kind of learn as we go through all the changes. Like it's going to be very confusing to try to learn Gremlin on the first edition if you're using something recent. So hope to have that out soon.
Yeah, that'd be great. Yeah, it's a great resource. To showcase what I mean with why I think it's a really valuable data set to walk the graph, I want to do a quick little demo here, and I want to do something a little bit fun. So we've got Rexter here, and Rexter really wants to travel from Rex Airport to Cat, which I thought would be fun. So if we jump over to my console, we'll get started on our journey here.
I think I'd rather be flying with Rexter than flying with Gremlin, to be honest.
I think, yeah. I don't think I trust Gremlin.
I'd rather him be on the controls, dude.
I don't know if I trust Rexter that much either. It doesn't look the most in control of the plane. But, yeah. Can we just switch to the console here? Yeah, so this is just a standard 3.8.0 Gremlin console, and the first part I want to show is the easy part. You can now create air routes just straight out in TinkerFactory. So that's super easy. Got the whole graph here. That's just really nice convenience for new users. I'll get a graph traversal source from there. I just want to start by verifying both of these places exist. And they do. So Rex is Reynosa in Mexico. Cat is Cascais in Portugal. So we'll try and find a route between them. Just going to start with a pretty standard sort of query to try and find a path. So we're just going to start over here at Rex. And we'll do a repeat. And we're just going out repeatedly. We're going to keep going until we find Cat. The dedupe here is just an optimization. It's to filter out any nodes that we've previously visited, so we're not constantly looping. But essentially, we're just going to keep exploring those out edges. And this is what airroutes is just really great for, because airports, the only out edges is these routes to other airports. You can just keep chaining them. You don't need to worry about filtering labels, anything like that. Every airport has the same structure, so you can keep navigating the same no matter how far along the path you are. So what we'll run, I've just got a limit 1 on here. I'm just trying to see if a path exists. And I was quite devastated putting together this example, because you cannot get Rexter from Rex to Cat, which Rex is very disappointed by. So I'm just doing a bit of a pivot here. Want to see how close can we get Rex to Cat. So I'm just storing our Cat vertex on our path history here. Restarting the traversal at Rex. Similar structure, but this time just omitting every vertex we can reach from Rex, and I'm ordering them here by a bit of a calculation to order by distance based on the Latin long. It's not the most accurate function I've got here, but it's good enough for these purposes. And the closest airport we can get to Cat is Lisbon, which makes sense. Cascais is a suburb just outside of Lisbon. It's about a 20-minute drive, so that's pretty close. That's as good as Rex is going to get here. But really what I wanted to show off is that arrow is it's an easy graph to just start walking and exploring your routes. If we go back to our pathfinding, you can easily modify this to add different orderings or samplings or any amount of permutations to control how it explores each edge. You can try and prioritize different types of edges based on distance or whatever you want. So it's just a very easy graph to get used to and to navigate, and you can experiment with all sorts of different types of walks from it. So that's really what I like with Ergo. I'm really happy to have it built into TinkerPop now. Yeah, and that's what I wanted to show. So poor Rex can't quite get to Cap and get close. With that, let's jump back to the slides. And now I'll hand it off to Yang to go over some of our new steps.
Yeah, thank you, Cole. Yeah, I think also with this new edition, it's also, you can explore Calvin's practical Gremlin book while have some live console to play with. So I think
that's way easier too. Yeah, when
Yeah.
I first picked up Practical Gremlin, it's not like it's hard to load air goats before, but you need to import the data set and stuff. And
It was nice tearing out all of that content out of the book and just saying all you have to do is just do this.
that. Yeah.
It's
It was
great having
like one line of code versus a lot of explanation and downloading things from GitHub. And yeah, this was this should have probably happened a longer time ago, but there it is.
Yeah. Okay, cool. Shifting gears to some of the new steps we're introducing. So one of the first step we have is the type predicate. So it allows filtering of traversers based on their type. Right now, it accepts a set of data types, which we actually defined into an enum called G type, as well as string representation of class names that's registered in a type cache. So that's built to allow provider to supply their own data types. So just a quick note, we actually, we don't officially have any type system in Gremlin for now. So we have this enum called G type for kind of a set of kind of regularly used Gremlin specific types. And I'm sure that will evolve over time, but right now that's what we have. So this is a particularly useful predicate for filtering heterogeneous data scenarios and to perform filtering based on element types. So interestingly, this was a feature that was actually requested 10 years ago, but it was closed due to limited community interest. And then we had recently, about a couple years ago, we had a community request in Jira that actually renewed this interest, which led to its inclusion in this major release. And so, yeah, next slide, we have some examples. So this is these two are actually relatively simple examples. So the first one is just where we in the modern graph. So that's a modern graph where we have integer data stored in age and then string data in name. We get a set of that data returned. And then, if I just want integer data value returned, then I can just use this predicate to filter. And the second one, it's slightly more complex, but it's also very simple. So it just shows how we can pick specific element types. So edge in this case in a path, so where all the traverse objects are returned. So this use case can actually be extended when, for example, when you're using the choose step, where we can apply conditions based on the type of element we encountered in this path. Yeah, so that is the P dot. So for additional, notes and examples, check out the upgrade and the reference docs and give it a try. And then moving on. So we also have a number as a new second set of casting steps. So the general idea, so for Gremlin, we actually, without casting, so data, they're either silently filtered or they just cause exceptions. So now when we want to have a casting step, but however, having a simple step will get too complex and confusing, especially when graph elements come to play. So there will be too many conditions. And then what happens if we're casting a number into a vertex, or like what does a path casting into an edge mean? So then we decided to break them up into kind of type, umbrella type. So basically the as number step, it will convert incoming traversers into a logical parsable type if there's no argument provided, or it will cast it to a desired numerical type based on the type token provided. And so this new step will allow users to normalize their data by converting strings, numbers, dates, and the mixed numerical types into a consistent format. So that should make it easier to perform downstream operations, such as some mathematical operations. So as exemplified in our next slide. Yeah, so basically, the sum step can only take numbers, or in this case, you can see we have a casting exception. So now one can use the as number step to convert the data into a consistent numerical format. So by default, this should just be using the default. I think it's a double. I could be wrong. It could be big decimal. But basically, what happens is it will now with this we can avoid casting exceptions and then get a proper sum output. And then in extension, we can further cast these data into desired types. So for example, our sum returns double by default. And then so if we don't want to store that as a double, we can store that as an integer or even long or any other numerical types that's available in the G-type enum. So so check out the upgrade and reference docs again for more information on the usage. And continuing, and along with the as number, we also have the as bool step. That's for Boolean conversion. So it parses string and numbers into Boolean values. So the example here, basically, it's slightly contrived. Basically, we're looking at also the modern graph where we can use count to see how many of them have outgoing edges. Now we can also, when we cast it to use a Boolean to cast it, we get an array of nice true and false results that just simply tells you, if there is an out edge or not. So yeah, and then continuing on, we have data type related changes. So one of the so a key theme in 3.8 is consistency, especially moving forward. Yeah, that's all good. Especially moving forward, if we want to explore any sort of type system or even schema, consistency in data types is one thing, and also consistency in behavior is also something that's important, especially for user expectations while they're working with these steps. So as we added more casting steps, we identified an inconsistent null handling behavior. So after community discussion, we now standardize our casting step to just throw illegal argument exception when the traverser is null. So this is actually a breaking change to a string which previously passed null through. So that when you do your AI risk assessment, these should be sort of things that will be kind of noted and identified, and just be careful if you have that sort of data. Actually, I don't know. It depends on how you set it up. But anyways, so continuing on, we have, so, another part of, as we kind of, going through the existing types that's being used in Gremlin. We're looking to kind of deprecate some of the older data types used. And then, so for example, for date, so the default implementation of that has changed from the deprecated util date to the now more encompassing offset datetime. So the change that includes, so all of our date manipulation steps, it will still accept date for backwards compatibility, but it will return offset datetime. So this actually, probably something you would ask is, actually, what happens if you have date? Yeah, so that's where the breaking change occurs, where if for users, it's recommended to perform transformation in your database of date to offset datetime to retain this consistency. Because I think going forward in the next major release, we are looking to just strictly move to offset datetime, but that's to be discussed, I think. So yeah, and then I think coming up next, some additional date-related changes. I'll hand it off to Andrea.
All right. So continuing with our date conversation, I just want to briefly recap what the date steps do. So we have the as date step that converts strings and numbers to a date. And the brand new as number step, as Yang mentioned, converts dates to numbers. And the date add step that allows you to add or subtract a unit of time or to and from a date. And then the date diff step, which calculates the difference between dates. Below are just some simplified examples to demonstrate the basic functionality. Note that their date time function is used to create a date representing the current date and time. Next slide. Okay. So in 3.7, the date steps were kind of inconsistent regarding if they're going to be using milliseconds or seconds. So for 3.8, which was a result from direct feedback from the Discord Game Day event, the steps have been unified to use epoch milliseconds, which is the number of milliseconds since January 1st in 1970. So date diff was changed to return epoch milliseconds instead of seconds. The new as number step will convert dates to epoch milliseconds. The first iteration of the as number step actually didn't handle dates at all. But after the game day event and the feedback, we decided to add it. So it was really great to have that feedback during that event. The as date step has not changed and will still continue to accept the milliseconds. So with the consistency, now it's easier to chain and round trip date steps, which is helpful when you want to do any kind of date manipulation or computation logic. These two are really simplified examples to show how you can, for example, start with a birthday that's stored in as a millisecond string, and then compare that to the current date to find the time difference in milliseconds. And then the second is like a round tripping example where you can start with a birthday stored as a text pattern and then cast it to a date and then to a number and then back to a date. Next slide, please. Okay, so moving on from dates, the next few slides, I want to talk about handling of overflow and underflow. So in 3.7, the math operations would wrap around to the minimum or maximum values if there was an overflow or an underflow. This is not really ideal because traversals would start to produce inaccurate results once they reach like the type minimum and maximum boundaries. So these examples show how in 3.7, the byte overflow will wrap around to the minimum byte value. And then when you have an integer underflow, it'll wrap around to the maximum integer value. And for 3.8, we've changed it so that overflows and underflows will actually result in an automatic type promotion. Next slide, please. So for integral types, the sequence of promotion is from byte to short to int to long. And if you go beyond the long range, you'll get an arithmetic exception by default. For floating points, it goes from float to double to infinity. These are some simplified examples to show how the type promotion works. The first one shows how you can have an integer which underflows, resulting the promotion to a long. And then the next two shows how you can have a float overflow, and then it gets promoted to a double. And then if a double overflows, it'll go to infinity. And then the last example shows how the long can underflow can cause an exception. Next slide, please. So if you want to avoid all overflow exceptions or you want to avoid infinity for floating point, you can use the new as number step, really convenient, to cast to the extended types. So for the first example, you can see how you can cast doubles to the big decimals, and that way you can avoid infinity. And the second example shows how you can cast longs to big integer and avoid the overflow exception. Okay, and that's it for overflow handling. And I'm going to hand it off to Cole to talk about grammar.
All right, thanks, Andrea. Yeah, so there's a couple of new changes to the Antler grammar that I want to showcase here. First one is regarding construction. So first piece is that the new keyword is now optional. The new keyword most often seen when constructing strategy objects. So you can see our first example here. We've got constructing a subgraph strategy for with strategies. Before that new keyword was required, now it's optional. You can still use it. It will work fine, but it's no longer necessary. This was really done as the new keyword itself was really a legacy from coming from Groovy scripts, and it doesn't really provide any value. It's just unnecessary verbosity. Doesn't give any extra clarity in the scripts at all. So it really doesn't need to be necessary in the Gremlin grammar. Part of the theme with some of these grammar changes is that we're looking to sort of free the grammar a little bit from some of the Groovy legacy on it, let it be a bit more of its own thing. So we used to focus quite hard on trying to make sure it was always as compatible as possible with Groovy. That's still something we want to maintain within reason, but it's not as strict of a goal here. Like Gremlin to be able to evolve independently as its own language, without that tie to Groovy. One additional change here is the vertex constructor has been removed. So previously you could do this new vertex or new reference vertex syntax. This was mostly used for a from and to for an add e step. That's been removed, and the reasoning for that is that it was a bit inconsistent with the rest of the language. There's no abilities to construct other elements like edges and vertex properties in the grammar. So vertex was sort of alone and isolated in that regards. And also it was only constructing reference vertices, which don't include any properties. It's just an ID and a label. And that works fine for add-e, but in other usages, it could potentially lead to some surprises for users if they're expecting that to construct an entire fat vertex, or if they're expecting it to be attached to the matching vertex in the graph. So just to simplify it, we took that out there. We didn't really want to put edge and vertex property in the grammar to make that consistent. Figured it's simplest to just leave it without it. Constructing the vertex in your script is never truly necessary. You see in the example at the bottom there, you can directly use a V step in a traversal in from or to. That's always been supported. That continues to work as it always has. The extra piece that's also been added is you can provide a traversal that returns an ID, and the add e step will try and find that ID and attach it and use that for from or to. So those are the ways to use add-e now in scripts. Just directly use a traversal to produce the result you need. If you're using the graph traversal classes, any of the process API and any of the GLVs, you can continue to pass in a local vertex variable if you'd like. And under the hood, it just gets converted. It's essentially just a syntax sugar now, and it just gets converted to the traversal form under the hood in the scripts. The next set of changes I want to look at are with parameters. So parameters also have a long history with Groovy, where they used to be very important to use parameters in Groovy scripts, as Groovy script parsing can be quite expensive, and parameters allow you to take better use of Groovy's caching capabilities. In 3.7, parameters were added to all steps in the grammar as well to try and mirror that capability in Groovy, but the performance benefits just weren't the same because the Antler grammar itself was already much faster at parsing the scripts than Groovy was. So the parameters were kind of there. It was mirroring, it was giving some parity with Groovy, but there wasn't much of a purpose to using them. So we decided to take a bit of a different look at parameters in 3.8 here. To start, we've actually disallowed them in most steps, and I'll get more into that later. But we're trying to focus it to a narrower subset where it's most likely to be useful. And we're trying to make sure the parameters can survive for longer than just the script parsing itself. So in 3.7, as soon as you've run your script through our parser and it gets converted to a traversal, the parameters were immediately resolved and substituted in as values. So if you're trying to build any sort of caching mechanism that is leveraging parameters to increase the hit rate in the cache, the scope of that cache was really just parsing the script itself, and it couldn't include any traversal optimizations, which are typically done through strategies. So the goal here is to keep the parameters alive through those optimization strategies. And to do that, we've introduced this new structure called a g-value, which is really the representation of a parameter inside a traversal itself. And those g-values can be preserved throughout the strategy execution. And because we're able to keep those parameters encoded as g-values for much longer, that greatly expands the scope of what can be cached in a script cache. So instead of just being for the parser itself, it can now encompass traversal optimization as well. So this is really just trying to give providers new tools to build out some more optimizations on their end. This isn't something that expect all providers to support out of the box. This is something that it's there if they're trying to build such a caching capability. So consult your provider's documentation to see what recommendations they have in terms of using parameters and what sort of benefits you can expect to see from that. At the bottom here, I do just have a link. The full list of steps that take parameters are listed in the reference docs. It's mostly meant to highlight stuff like property values is the main sort of thing it's targeting. So far, there's not much parameters for things like property keys. This was a decision just to try and focus it on where we thought would be most useful for providers trying to build out a cache. If we put parameters everywhere, that greatly reduces the level of optimizations they're able to take advantage of while retaining the while retaining an optimized traversal that they can easily substitute parameters back into. This isn't necessarily a finalized list. This can always be expanded. We can put parameters in more places going forward. So look forward to hearing feedback on the current state of this and where we'd like to see parameters go in the future. I'll now pass off to Ken to talk about some other grammar changes here.
Thanks, Cole. So yeah, two things I want to touch on in this slide is the first is without strategies has been added to the grammar. So without strategies is something that's existed in the graph traversal source for a long time. So in 3.8, one of the things is we're trying to do is consistency and parity between like remote traversals and scripts is an important part of that. And so without strategies has been added to the grammar so that it can be used in scripts now. The second thing I want to sort of quickly mention is that the shorthands for map keys in the grammar will now value to string by default. So some of the things that existed in the grammar before were shorthands for some common enums like T and direction. There's some other shorthands, but what would happen is if, for example, in that top example where you do the g.merge e with the label sibling, if you didn't realize that label was a shorthand, it would, and you expected it to come out as the string label as the map key, it would do something completely unexpected, right? It would become the t.label instead. And so to sort of prevent this type of confusion for users, these will now be string by default, so that there's more things available for you to use as the map key. If you want the shorthand still, you can just wrap it in parentheses, like as is done in the bottom, where the label's wrapped in parentheses, or you can just use the fully qualified name. Moving on to the next thing is the changes in 3.7.5. So along with 3.8.0 release, there was a release for 3.7.5. The slide here is just sort of a copy of what was in the changelog. It's It's much smaller compared to 3.8. But as a reminder, these changes also exist in 3.8.0 as well. So most of these are sort of minor bug fixes, but I think one cool thing that's been added is the top level Gremlin examples. So if you're new to TinkerPop and Gremlin and you just want to have like a really quick start on like starting to query and try things with the GLVs in particular, so the drivers, then you can check out the top level Gremlin examples directory. These examples are very similar to what we had per GLV. So each GLV before had a sort of like examples directory, but now these are all sort of centrally located at the top of the repo, and they specifically use the released versions of the drivers and GLVs. So there's no building required. You can just sort of pull these and run them. So the old examples, they still exist within their own GLV directories, but those will run against your local build now. And so, yeah, that's one thing to check out if you're a newer user of Gremlin. If we move on. So yeah, big thanks to everyone that contributed to both 3.75 and 3.8.0. And a big thanks to everyone that joined the game day and provided feedback. We always appreciate and like feedback from the community. I do want to say that I think there is another planned Contributorcast to talk about the breaking changes, because 3.8.0 was so big, we couldn't get to everything. So there will be another one to talk about breaking changes and maybe a sneak peek of Gremlin MCP. I don't know. But yeah, thanks everyone. Are there any questions?
Looks pretty quiet on questions today. Is there anything in Discord? No.
Nothing in the events channel.
Okay. Yeah, I mean, there's a lot to take in. So by all means, yeah, please feel free to bring questions to Discord if you think of them later. And I think, yeah, like I said, I think this is like it's been said a few times. 3.8's a pretty big change. It's going to take a little getting used to for some of these things. So yeah, I look forward to getting any feedback on what's been put in here.
All right. If there's no other questions coming in, we'll wrap it up here. Yeah, thanks again everyone for joining. Thanks everyone for tuning in here. Yeah, I hope we get to hear your thoughts on the release in Discord, on the dev list, in the Gremlin users group. Yeah, thanks so much everyone. We'll see you again next time.
Bye everybody.